So with that, we can actually do the quiz now, or quiz practice questions. So the first things that I ask you to do is to write down half reactions for an equation. So what you have to do to write down half reactions, I'm going to start with an example here, is you have to identify the oxidation numbers. So sodium here is by itself, so its oxidation is 0. Chlorine is also by itself, so its oxidation is 0. But now here we have a combined element. So we need to figure out the charges by looking on the periodic table. So on the periodic table, I find that sodium is right here. So it has a +1 charge. And then chlorine is right here. Chlorine has a -1 charge. So I'm going to go back over here and call it +1 and -1. Okay. So if you notice, the sodium became more positive. We call that being oxidized. It was oxidized. And the chlorine here became more negative, and we call that reduced. So something that's oxidized loses electrons, loses electrons. And something that is reduced gains electrons, gains electrons. So if you are becoming your sodium and you're becoming more positive, that's because you are losing electrons. So sodium lost 1 electron here. And it looks like chlorine gained 1 electron. Because remember, electrons are negative. So if you lose a negative thing, you become more positive. And if you gain a negative thing, you become more negative. My teacher used to have us remember it like this: oil rig, and that stands for oxidation is losing, oxidation is losing, reduction is gaining. Oil rig. That's a weird A that I wrote there, but that's okay. Oil rig. Oxidation is losing, reduction is gaining, if you want to remember it that way. And so to write the half reactions, we're going to split this up. We're going to write the sodium, and we're going to write how the sodium on this side had a +1 charge. So the sodium here was 0, and now the sodium has a +1 charge. And we're also going to write down the coefficient in front, the 2. So you can see here, we're just kind of showing the process of sodium gaining a charge. But we want to show what happened to the electron. So the sodium must have lost an electron on this side, right? Because here it was at 0, and now it has a +1 charge. So there's an extra electron floating around because oxidation loses electrons. And we want it to, we have 2 sodiums here, right? And 2 sodiums here. So technically it's losing 2 electrons. And now we're going to do the chlorine. First we had Cl2 on this side, and then it became 2Cl with a -1 charge. And so there must have been, the chlorine here was 0. So there must have been an extra electron on this side because all of a sudden it gained it over here, right? And in order to write that, we also, there's 2 chlorines here and 2 here, so we need to put a 2 right here. And if you notice, they cancel out when you add them together. So these are called half reactions. You kind of split them apart and you show what's happening to the electrons. And because here sodium is being oxidized, this is the oxidation half, and this is the reduction half right here. Okay, so now let's practice again here. What would be the oxidation and reduction half reactions for this equation? So the first thing we need to do is identify the oxidation numbers. So CaCl2, we're going to go pick that up from the periodic table. We're going to find Ca, and we're going to find Cl. So Cl has a -1 charge, and Ca has a +2 charge. So I'm going to go ahead and write those down over here. Ca is +2 and -1. But you notice, how many chlorines do we have here? We have 2 chlorines. So do you see how overall it nets out to 0 because there's 2 sets of chlorine? Now copper here is by itself, so it has a charge of 0. Copper here, though, is not by itself, and so we need to look up the charges here again. Chlorine still has a -1 charge, okay? Copper, when we look up copper, it does not have a set charge because it is a transition metal. So we have to figure out what charge it has. The way that we figure that out is we can just kind of think backwards. So we have 3 chlorines, each of them have a -1 charge, right? 3 chlorines, each with a -1 charge. So that comes out to -3 total, right? If you add those together. Well, that means that copper has to have a +3 charge because ionic compounds have a net charge of 0. So copper is going to have a +3 charge because the total charge on this side is -3. And then the calcium here is by itself, so it has a charge of 0. So now we've identified all of the oxidation states. You can always Google some of this if you need confirmation about your choice. And now we have to figure out which one was oxidized. So if you notice here, the copper went from having a charge of 0 to having a charge of +3. So the copper was oxidized. And then if you notice, the calcium went from having a charge of +2 to having a charge of 0. So the copper was reduced, and then the chlorine didn't change at all. So we're not going to look at the chlorine. So let's do the copper part first. You basically just copy it down, and you only show the part that has copper in it, and you also show its charges. Okay, so copper went from having a charge of 0 to having a charge of +3. So it must have dropped off 3 electrons here, right, in order for that to happen. But we have 2 sets of it, 2 sets of copper. So it would have dropped it off twice, right? Because there are 2 coppers here. So rather than writing it out like that, we can just call it 6 electrons that it dropped. Because there are 2 sets of 2 of them, that each of them have a +3 charge. So it dropped off 6 electrons. This is the oxidation half reaction. Okay, now the reduction one, we got to show that calcium, it had a +2 charge. I'm just copying this part right here. Okay, and then on the other side, it had 3Ca with a 0. Okay, so we must have had some extra electrons over here that it picked up. It must have picked up 2 electrons, each one of them, but there are 3 sets of them. Okay, so three times it picked up 2 electrons. And so really 3 times 2 is 6. So we can write it like, I'm running out of space here, plus 6 electrons makes 3 Ca over here. So this is called the reduction half. Okay, so we basically figured out which one was oxidized and which one was reduced, and we found their oxidation numbers. And we kind of split it up to show what was actually happening and where those electrons are going. And if you notice, this is 6 and this is 6. And that should be the case. The numbers should match when that happens. Okay, so let's try one more practice now. And again, this is framed almost exactly like another quiz question that you have. So you're going to want to write it down so that you can actually write on it like I am. Let's find the half reactions again. So we're going to figure out their oxidation states again. So the copper here has a charge of 0 because it's by itself. Same with the hydrogen on this side, it's by itself, so its charge is 0. But these 2 are combined, and so we have to look up their charges on the periodic table. So if you were to look up on the periodic table, you just find them right here, right? H is +1, Cl is -1. So the first part is going to be +1, -1. Let's see, +1, -1. And then here, when we find copper on the periodic table, again, copper is a transition metal. So its charge is not set in stone, and we have to figure out what charge it actually has. So chlorine still has a -1 charge, but there are 3 sets of chlorine, right? -1, -1, -1. So the net charge over here is -3. That means that copper has to have a +3 charge because the overall charge of any ionic compound is 0. So that 3 cancels out with that -3 to make 0. So now we have to figure out which one is being oxidized. Which one is losing electrons and becoming more positive? Well, I can see that the copper is becoming more positive. So I'm going to write down exactly what I see here, but I only want the copper aspect of it. And I'm also going to write down the charge that it has here and the charge that it had here. So it looks like copper must have, if it has a +3 charge, it must have dropped off 3 electrons in order for it to have a +3 charge. So it dropped off 3 electrons, but I have 2 sets of copper. So if it dropped it off twice, it would be 6 electrons, right? So this is me reflecting what actually happened there. All right, so now we're going to write the other half. You can see that the hydrogen, had a +1 charge here, and then it went to having a charge of 0 here. And so we're going to just write that out, but you're only writing the part that includes hydrogen. Okay, so where should we put the electrons? Well, it looks like you basically put it on whatever side the positive charge is on. So see how the positive charge is over here, so the electrons go there. So the electrons go on this side this time, and each one only has a +1 charge. But how many do we have? Well, we have 6, 6 sets of them. And so we'll say +6 electrons, right? And so this is the oxidation half, and this is the reduction half right here.